model predictions. And then I'm going to show you, recently they've been plotting the same graphs of real-time observations. So the models, the math that everyone's plugging, are conservative than the real-time observations. So we're looking back at the data from 10 years ago and what we predicted according to the models, and the real-time evidence is far exceeding what the models are saying. So reality is worse than what the models are. And this recent, in Mexico, they had the climate change conference this year. They sold us out again. So we asked for 260 to 300 parts per million, and the United States kowtowed with all the other industrialized nations, and they're going to go for 450, which is a death sentence for mangroves, shellfish, and corals. We'll live, sea level will rise, but all of these organisms, as we know them, will be gone, and there will be a massive migration of small island nation peoples to larger countries because they won't have fisheries, they won't have food, they will not have shelter, they will not have shoreline protection because there'll be loss of these ecosystems that protect the shoreline.
Speaking of the United States, Secretary of the Interior just okayed deep ocean drilling.
Yeah, nice.
Oil. Is
Love
there a effect of temperatures within the water column from that activity that we should be concerned about?
No, it's just pollution. It's just going to be pollution.
What effect is methane?
Methane is a stronger greenhouse gas than CO2. Methane and H2O, actually water vapor.
The reason I'm asking the next question is microbes, and the speculation was that the microbes are doing a nice job of cleaning up the heavy oil. But what I think a lot of people didn't realize was the release of methane was almost as bad or worse than the release of the heavy oil.
It's 20 times worse than CO2. But the little microbes are not degrading and using it like we want them to use it. Again, it's all time, evolution. And the problem is that this stuff...
These are the natural microbes in the
Yeah.
ocean, not injected ones.
Right. Neil, where is that again? If I...
To get back into the...
Yeah, it's in my computer.
Yes.
Yes.
Yeah.
Okay, I got the graphs here that I want to show you. Put the wrong one on, I'm sorry. Okay. So this was the one I was putting up there. This is just some pictures of the Antarctic ice sheet from 1992 to 2002, and this is goes back to that other question of the record. The record has never shown this much decrease in ice that fast. Yes, it showed decrease in ice from past records, but never this fast. The ice melt this, unless a meteor slammed into the Earth. But other than that, the gradualism. Okay. So Hansen, anybody hear this guy? This guy was really super brilliant, and it was great because he saved all of his emails and he saved all of his letters and threats and recorded people that that they threatened him to not show his data. And I remember back in the 70s, he was so beaten up by certain political parties for coming out and having this gloom and doom theory that he got so, shell-shocked that he went away for 10 years. He didn't go away, but he just shut his mouth for 10 years. And then right before retirement, in the last 10 years of his employment, in the last 5 years of employment, he just came out with the data. And he was hammering, showing the truth, showing how his data was suppressed, and his science is well respected by over 3,000 scientists globally. But he's been warning about this, and he has the data. He can explain to you and show the world that greenhouse gases and what we're adding to the system is trapping the heat far more than we ever imagined. But here's methane, nitrous oxide, and CO2. So NOx is another greenhouse gas that we need to be worried about. Methane, they're all on the rise since the Industrial Revolution, and they're all serious heat trappers. This is what I like this graph Hansen made up, because this is showing you the model, and then the red is the real-time observations. So the model observations have been conservative compared to the effects, like right here. Look at these gaps. This is what the mathematical models were showing, and the actual reality of CO2 increase and temperature anomalies were far more than anybody imagined. And this is the Mann hockey stick curve. I call it a hockey stick, and you can see here. So the gray is reconstruction. Over time, you just see that this, no matter what, there's an upswing in global sea surface temperatures, and 1998 being the hottest year on record. Now we don't have to say 1998 was the hottest year on record. This year, with all this snow, that's why you got to be careful. People say, "Oh, global warming, it's been snowing." Well, weather is different than climate, and that's what everybody needs to understand. This year we in our little world here in New York, it's been very cold and had a lot of snow, but globally we've broken records everywhere. Corals have been bleaching and dying at unprecedented rates. Mangroves and shellfish beds all over the world are collapsing, and the highest rate of acceleration of ice melt ever seen before this year. So 1998 is no longer the hottest year on record. This year will be exceeding that.
How is the temperature measured? How is it averaged over the Earth?
Oh, they average it from Mauna Loa, Hawaii. They picked that area in Hawaii as a control because it's far away from any anthropogenic inputs. Not in Hawaii, but like out in one of the islands.
Yeah.
They measure the average there.
What about the theory that
But it's just there, or do they measure
Oh, everywhere.
other
Every the plots, but that's sort of like the control, and then they
Yeah.
put all these numbers together
Okay, yeah. So they
communicatively. Yes.
what about the theory that if it warms up, it'll just snow more, so that it'll the ice will melt, but then there'll be increased precipitation, which will then freeze. And
Well, the whole thing is these things are going to happen, right? Or some of these movies, they accelerate the rate of how it's going to happen. It's going to happen a lot slower, but you're changing the ocean's salinity, and these critters that are there are used to a certain salt type of water. They're not going to live. They're not going to absorb stuff. So some of the movies that you might see about the increased snowing and going to a global cooling, that's over long periods of time. Life as we know it, as many of you people here in the room, being in science, I was taught by pioneers, the old timers, the people, the scientists that had fathers and grandfathers in the business, and I noticed that all the new scientists coming to the show today don't have a respect for the pioneers and don't have a respect for the literature that was published back in the 40s, 50s, and 60s. I see a lot of science that's being reinvented, and I actually take points off and impact my students' grades when they're not citing stuff from the 30s, 40s, and 50s. I make it mandatory if I don't see a reference list, because that's when all the ideas first came out. Not to mention that the old-timers remember what it used to look like. So all these new hotshots, these kids that are coming out, Ph.D. scientists, they go to the Caribbean and they're like, "Oh, it's beautiful, and we did experiments, and wow, and some of this looks great, and yes, a lot of it's dying." How do you know? Do you even ask some of the old-timers what it used to look like there? Your reference list is citing stuff that's been published in the last 20 years. And when some people say that certain areas in the Caribbean are coming back, they're really crazy, because it's not. But when you talk to the old-timers, the people that remembered, the scientists that I hope a couple of them were going to be here tonight, they remembered what it looked like. They know you're not going to pull the wool over any of their eyes. But politicians and policymakers, they don't ask them. They ask all all the people